Assalamu alaikum and good morning everyone. My name is Umar Al Farouk from Idrisi International School, and today I am proud to present a project called Safe and Snug, which is a smart baby car seat alert system developed as part of a project-based learning initiative. And this wouldn't have been possible without the guidance and assistance from the CPE team, the Center of Principal Electronics from University Malaya. Here is the outline of my presentation. I will begin with the motivation of this project, focusing on its relevance to engineering education. Next, I will show you the educational framework we adopted along with our case study, the Safe and Snug project. I will then describe the key educational outcomes, and finally, I will conclude with the main takeaways. The motivation for this project is to address both Malaysia's and the global priority of strengthening STEM education in high schools. To achieve this, learning must be engaging, experiential, and impactful. We know that students learn best when lessons are engaging, hands-on, and connected to real life. Instead of focusing only on theory, they need opportunities to apply what they learn to real challenges that matter to society. That's why collaboration between universities and schools is so essential. It makes learning more authentic and applied. Through approaches like project-based learning and inquiry-led teaching, students don't just study engineering, they experience how engineers actually work, by solving problems, testing ideas, and working as a team. In doing so, we are supporting global priorities such as SDG 4, quality education, and nurturing the mindset of socially responsible innovators who can contribute to the well-being of communities, which aligns with SDG 3, good health and well-being. There is a clear shift in today's education. We are moving away from rote learning and more towards 21st century competencies like critical thinking, problem solving, and teamwork. To build these skills, students need authentic, real-world projects that truly engage them. Case studies have shown that engineering education thrives when learners work on real problems, whether it's creating safer spaces, building robots, or supporting communities. These initiatives shows the power of learning by doing. For example, in Danbury, USA, high school students worked with marine engineers to build and test underwater ROVs, learning fluid dynamics, coding, and design in the process. At Texas A&M, the Aggies Invent Junior program brings high school students together with university mentors to tackle real-world engineering challenges through design and prototyping. Last but not least, at UC Berkeley, the Pioneers in Engineering (PIE) program sees undergraduates mentoring local high school teams to design and build robots for competition, promoting STEM learning through peer-to-peer collaboration. I would now like to share a case study. This project began with a very real and heartbreaking issue, that is, the rising number of cases where infants have been accidentally left in cars. As you can see from these heartbreaking newspaper headlines, this is not an isolated incident, but a growing concern that has led to the tragic consequences. This phenomenon is known as forgotten baby syndrome, and it reminds us how critical innovation can be in protecting lives. In response, Safe and Snug addresses this issue. A smart baby car seat alert system supercharged by IoT technology designed to provide both safety and a peace of mind. This initiative started when our school approached the CPE team from to explore a university-school collaboration. The goal was to mentor a group of us 16-year-old high school students and to strengthen our team learning through an integrated approach. From this partnership came a problem-based learning case study, Safe and Snug. Mentors from CPE visited our school to introduce us to the engineering design process, and later we also had the opportunity to visit the CPE lab at University Malaya, where we gained real hands-on experience with sensors and microcontrollers. These sessions gave us new learning opportunities that went far beyond the classroom. Through this project, we experienced several key pedagogical approaches, such as the problem-based learning, design thinking, experiential learning, scaffolded learning, collaborative, and inquiry-based learning. And alongside these approaches, we developed number 1, technical skills, number 2, engineering practices, lastly, soft skills such as communication and critical thinking. Educational framework. I will now walk you through the entire process, step by step. We first began with researching the problem, reviewing journal publications, and collecting feedback from parents and caregivers to understand their needs. From this, we analyzed the market, identified the key issues to address. The next stage was ideation, where we brainstormed ideas, generated multiple concepts, and explored possible solutions. This was followed by the design stage, where, with guidance from our mentors at we developed the system architecture, identifying both the hardware and software components to be used. After that came prototyping, where we built our first ever version of the Safe and Snug system. This was followed by the testing and evaluation, where we tested the prototype with real users, gathered feedback, and assessed its performance. Based on its feedback, we moved to the refinement stage, troubleshooting and making improvements to resolve issues identified during testing. And finally, we arrived at the completed version of our case study system. As part of the final stage, we summarized our design into 5 key specifications. First, the user needs. Next, usability and safety, ensuring the interface is clear and the device does not compromise the child's comfort. Thirdly, functionality, combining presence detection with temperature monitoring integrated alerts. Fourth, cost and manufacturability, keeping it affordable. And lastly, the marketability, making the system adaptable, accessible, and filling a gap that many commercial products currently do not address. Now, I will be talking about the design needs hierarchy and about some commercial baby car seat alert systems that currently exist. On the right, we have a table displaying the design needs hierarchy. Based on input from parents and caregivers, it helped us focus on the most critical needs first, while still considering extra features for the future. The highest priority needs were to detect the presence of a child in the car seat, monitor the in-car temperature, and notify the caregiver immediately through alerts. At the other end, the lowest priority was enabling offline alerts via SMS or GSM modules, which we viewed as an additional feature for future development. And over here is a list of existing commercial baby car seat alert systems, showing their main features and limitations. From this view, we can see that while these systems provide some level of safety, they often come with limitations such as high cost, limited compatibility, reliance on Bluetooth, or lack of environmental monitoring. This gap highlights the need for an affordable and adaptable solution like the one we developed in our project. In the ideation stage, we explored design alternatives for each subsystem of a Safe and Snug system, such as detection, alerting, and user interface. Using a concept generation table and a decision matrix, we compared options against criteria like cost, accuracy, complexity, and user experience. The decision matrix in the middle here showed concept A as the best choice due to affordability, reliable parts, and suitability for educational use. This slide shows the Safe and Snug system during the design phase. A weight sensor detects if a baby is present, for example, more than 2.5 kilograms, and sends a notification to the caregiver's mobile app. The system also includes a 1-hour take a break reminder and continuous temperature monitoring, with alerts when thresholds are exceeded. On the right is the system overview, as you can see, showing how the sensors, microcontroller, and app work together in real time. The prototyping and testing phase was very hands-on. At the CPE lab, we assembled off-the-shelf sensors and integrated them with the ESP32 microcontroller, learning both the hardware and software aspects of IoT. The system was then tested under simulated conditions. It correctly detected a baby's presence at 5 kilograms, triggered an overheat warning at 38 degrees Celsius, and a critical alert at 42.5 degrees Celsius, confirming that the sensors and alert logic behind the app worked as intended. To conclude, this project shows how real-world problems can drive meaningful STEM education. The Safe and Snug case study demonstrated how students can apply engineering design thinking to address a real societal challenge. Here are some pictures of our activities. The team from CPE University Malaya came to our school to give us lectures on the prototyping and design process. We also had the chance to visit the CPE lab where we carried out hands-on assembly and testing activities alongside our mentors. We are also proud to share that our prototype design was submitted to the Malaysia Technology Expo 2025 (MTE) in late February this year, where we won the Gold Award in the Safety and Security category. We also received recognition from the INOPA. In addition, our achievement was featured in the Star newspaper, which gave us further encouragement and visibility of our work. Thank you.